Now I will count to 3 for each page. That is 4 pages now. Okay. For the page 1, 1, 2, 3. Okay. For page 2, 1, 2, 3. Okay. Next for page 3, 1, 2, 3. Okay. Now for the last page, 1, 2, 3. Okay. Thank you very much for all the guests and audiences. Now we will begin our first session of this international webinar. Our keynote speaker in this section is Dr. Hashem Salarzadeh Jenatabadi from University Malaya, Malaysia, with the topic of Introduction to Structural Equation Modeling and its implementation using with Amos. And the session will be moderated by Ms. Dita, a Master of Science, a lecturer of Statistics undergraduate program, Universitas Airlangga. For Ms. Dita Amelia, this place is yours.
Thank you, Ms. Rani. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, ladies and gentlemen. How are you today? I hope all of us in a good health and ready to start this amazing discussion. Welcome to our great participants from around the world: Indonesia, Malaysia, Filipina, Iran, Timor-Leste, Bangladesh, China, Algeria, Yemen, Jordan, Jamaica, and Nigeria. Welcome to this session. My name is Dita Amelia, your moderator in this session. We know that structural equation modeling is one of statistical methods in multivariate. Nowadays, some very popular and social science and other fields such as psychology, sociology, management, and accounting. How the implementation of structural equation modeling we will discuss with our great speaker. Okay, we will start with the presentation of the speaker. Our speaker today is Dr. Hashem Salarzadeh Jenatabadi. Good morning, Dr. Hashem.
Morning. Good morning, Dita Amelia. Nice to see you here.
Okay, nice to see you. Okay, Dr. Hashem Salarzadeh Jenatabadi is a senior lecturer from Department of Science and Technology Studies, Faculty of Science, University of Malaya. He holds postdoc PhD degrees in Applied Statistics from University of Malaya and Master Bachelor degrees in Mathematical Statistics areas from Ferdowsi University of M.Stat, Iran. His expertise involves application of statistical and mathematical modeling in engineering, management, public health, chemistry, and economy. Okay, in this session, the speaker will present the topic for 90 minutes, Dr. Hashem, and then will it be followed by a question and answer session for 15 minutes. To participants who will ask question can write in chat room, in Zoom or YouTube, or you can use raise hand icon after the speakers present his presentation. Dr. Hashem will present about introduction to structural equation modeling and its implementation with Amos. To Dr. Hashem, time is yours.
Okay, thank you so much, Dita Amelia. Good morning, everybody. First of all, it would be my great honor and pleasure. Pardon?
Good morning.
Can you hear me? Oh, good morning, good morning, good morning. And very nice to see all of you. And I hope, good morning. And it would be my great pleasure and honor to join for this international webinar, Structural Equation Modeling, which is my favorite topic, actually. And first of all, I would like to thank to Prof. Eridani and Dr. Fariz to invite me for this international webinar. And second of all, I would like to thank you to the research group of statistics of economic and social science. And here we are to present talking about the structural equation modeling and its application in other sciences. As Dita Amelia informed you, I'm a statistician. I have done my bachelor and master on mathematics statistics from Iran and Ferdowsi University, and I have done my PhD and postdoc in Applied Statistics Department, University of Malaya. So let's start to talking about what we want to do for today, right? So so this is my introduction, and yeah, already Dita Amelia introduced me, right? So today I would like to talking about 4 main topics, and what is SEM, and every of us aware about the SEM. In the last 3 decades or 4 decades, SEM is become is very among the researcher, and especially as a statistician, help us a lot to figure out some previous issue that we had for the modeling, right? And after that, I give you examples, but actually this is the rough, doing data analysis, because normally structure equation modeling with Amos takes around 3 days, right? But I have just maybe half an hour or 45 minutes to explain to you what I'm doing with the structure equation model with Amos. And after that, okay, what we have, yeah, Amos software, we know Amos software. So what should we do? The next step I would like to teach you, especially for the PhD and master student, 10 steps for preparing research thesis based on the SEM, right? Because the SEM has their own structure, and when it's coming, totally the way of the writing thesis, the way of the writing papers totally is changed. You should follow the structure of the SEM. And then after that, I would like to review 5 of my paper with the SEM, and how did I combine SEM with the other methodology, which is very helpful to publish your paper in a high-ranked journal. So with any further question, we go for first slide. Oh, there is okay, it's not about me. Okay, there is a message. So, okay, normally, what is the SEM? People thinking about the SEM like a technical or something like that. No, actually, from the statistician perception, SEM is a general model framework. It's not just like a regression. It's not like a factor analysis. No, it's not like, logic model that we have done so many data analysis before. No, SEM actually is a framework, right? And what is the integration of the SEM? SEM is a combination of the measurement theory, factor analysis with the latent variable, path analysis, regression, and simultaneous equation, right? So this is the main differences between the structure equation modeling with the regression analysis that we know about it before. The regression analysis, you can see you have so many independent variables, just one dependent variable. Of course, maybe you can have different dependent variables, but for every dependent variable, you will have different model. But the structure equation modeling, which help us to improve our modeling, is like we can have many independent variable and dependent variable in the same model, not in the different model, right? But the only thing that added here, just very strong feature of the structure equation modeling, adding 2 types of the variable, which is mediators and moderator. And I would suggest to my student and also to participant student also here to how to deal with the mediator and the moderator. And the mediator and the moderator, which is helpful to come up with some new ideas for the new framework. If you know structure equation modeling, if you know how to design your research framework, you can do so many things. You can do so many modeling with the causal relationship with so many variety of the variables, right? So this is the main differences between structure equation modeling and regression. This is the differences, the path analysis, which is part of the structure equation model, and the factor analysis, right? With the factor analysis, all of us, we know we are statistician and mathematician, right? So Factor analysis, we go for, data analysis for many factors, put together. And for example, socioeconomic status, further education and mother education, further occupation. And then also like education study, school achievement, math score, science score, and English score, and then career success like salary and job satisfaction, right? So for the factor analysis, we just find how the factor loading of the every measurement, every small variable, how to relate it together, how we can categorize them. But in the path analysis, we combine all this factor analysis to one, call it latent variable, right? So this is, can see that the factor analysis also inside the path analysis, right? So we talk about the latent variable, right? So normal in structure equation modeling, latent variable is sometimes called it unobserved variable or construct, right? So normally latent variable measured directly. We should come up with the combination of the some variables, which is called it measurement variable, right? When we're talking about, for example, business, right? Business strategy have so many items. Firm performance include financial performance, operational performance, and business performance. So this is, every of them is called a measurement variable. When we're talking about the performance of the company as a general, it's not you can measure it directly. You need to combine some measurement variable like financial, operational, and business performance, right? So as I said, the symbol of the latent variable is oval, and the symbol of the measurement variable is like a rectangular, right? This is the main thing or main symbol of the relationship between the latent variable and observed variable. One thing that we have here in the error term, which is cannot find it in structure, in linear modeling or even general linear model. We can have it here in SEM or structure equation modeling. So I'm moving very fast because I would like we reach the main part that is my concern, how to use SEM to prepare your thesis, to prepare your papers, right? So this is the symbol, and then normally, as I said, for the measurement variable, we use rectangular. For the latent variable or observed variable, or sometimes we call it construct. It's like the symbol is oval, and then also arrow term, like a circle, right? And then you can see one one direction arrow is called it for the regression, and then if double arrow or two-way arrow is called it covariance or correlation between two latent variable or two measurement variables. So this is the main symbols of structural equation modeling, right? So let's go back here. There is a very simple way. We have two type of the measurement. One of them XT. This is like call it two correlated causes. Very simple. And then this is indirect effect. This one I would like to add you something that is which is very important when you are doing the structure equation modeling analysis, which is normal. You have done many times for the direct effect. For example, beta 1, which is affecting the x1 over the y, is the direct effect of x on y, right? So, however, we have also beta 2, direct effect of x1 on x2, right? Here we have also beta 3 is direct effect of x2 on y. However, the combination or the multiple of the beta 2 and beta 3 is indirect effect of x1 on y. So normally, when we're talking about the coefficient analysis, we're always looking about the direct effect. But however, in the structure equation modeling, we have indirect effect, right? So if we consider x over the y has a direct effect from here. We have indirect effect through x2 over the y, right? This is one thing that the feature of the structure equation modeling. Moreover, we would like to have the total effect, right? The total effect, which is direct effect plus indirect effect, right? So direct effect plus indirect effect, which is total effect of x on x1 on y, right? So as I said from the beginning, the main concern, the main thing in structure equation modeling that added two type of the variable is a mediator and moderator. You see, if we have a mediator, if we have an independent variable and we have dependent variable, which is so common in modeling, and the coefficient effect of the independent over the dependent is called C. There is another variable which is called mediator. It means that moreover, independent variable direct effect on the dependent variable has is relationship between the independent and dependent. However, we do have another type of the variable. It's called moderator. As you can see here, we have two type of the moderator, right? Moderator variable 1 and moderator variable 2, which is can affect in the relationship between two variables, not between two variables, in the relationship between two variables. So I go back to my point here. If you really about how to use mediator and how to use moderator, you can come up with so many of to come up new idea, new theories of the sorry with application of a structure equation model in your topic. Maybe you heard about, for example, the theory of planned behavior, right? And or Winkotish, right? There are some theories that like some framework is designed some people previous before, and then some coming out, for example, extended theory of planned behavior, right? So which is improvement of the theory of planned behavior with adding some variable based on your topic, and or you know with adding one variable or many variable based on your topic, which is want to use the theory of planned behavior in your area. So this kind of variables, as I said, mediator and moderator, will help you a lot to come up with some new idea, right? So moreover, we do have, sorry, we do have three type of SEM analysis: reflective and the formative. As you can see here, the definition of the the differences between the formative and reflective is based on the type of the arrow, right? Here, the X1 can affect to the latent variable, life stress. However, to the measurement variable. So when the direction of the arrow towards latent to measurement, this make it different. Comments call it reflect. If we have X1 accumulate last minute request, X2 punctuality in
Recording in
see
progress.
that, for example, life stress include job loss, divorce, and recent accident, right? However, in the formative, there is no correlation among the measurement. So this is different type of the structure equation modeling. One of them is doing based on the Amos, the other one is doing based on the partial least square. This is beyond of our workshop for today, right? So let's move on to the next slide. The structure of the SEM, we have two parts. The first part, we're talking about the measurement model, and the second part is like a structural model, right? So here that we have, for example, measurement model, which is confirmatory factor analysis, and you can see we're just analyzing, for example, one latent variable, for example, psychological health, and with measurement variable like hostility, hopelessness, and general health question, right? And self-related health, right? As you can see that for the measurement model, we're just talking about latent variable and their measurement, right? So this is the confirmatory factor analysis for the first part of the measurement model. As you can see here, the another name, sometimes the observed variable is called it manifest variable. And yeah, this is the structure of the measurement model. However, the structure model, you have additional variable here. Moreover, you have latent variable here with its measurement variable. We also have additional variable, right? So this is so clear. There's also error term. There's also error term, right? And then we have some variable like education, like occupation, and like income. So you can see that the differences between the measurement model and also structural model. Structural model, we're talking about measurement model with adding some variables, right? So this is another design, which is sometimes called it causal model or path analysis. And for the path analysis, moreover, you can see some variable here, right? You see 1, 2, 3 measurement and one latent, which is one latent have 4 measurement variable. There is a path. You see, there is a direction here. So that's why it's called path analysis or causal modeling. There is a path. You can see the education, go to psychology, or education, go to the income, go to the psychological health. So that's why you can see the new definition is a path analysis. So actually path analysis and structural equation model, all this in the path analysis, which is structural equation modeling, which is there is a path among the research variable, right? I hope until here you understand the differences between the path analysis and structural equation modeling. And the structural equation modeling include 2 parts, measurement model, right? And we do it in structural equation model with Amos later, and also with the structural model, right? So if you design a framework, right? And then you can put dependent variable, the independent variable. And the first question normally my student ask me, so how we can trust this model, right? Which is true, right? We cannot just put all the things together and then they said, oh, this is, correlation between the research variable, and then this is dependent, this is the independent mediator, and that's all. No, we have to evaluate the model, which is called it fitting model, or how we can evaluate the good model. It's called it fitting model, or sometimes I put here the foot measure. based on some statistics. What is that statistic? The chi-square test, CFI index, which is comparative fit index, Ramsey, root mean score error, and TLI, Tucker-Lewis index, and GFI, goodness of fit index, and then many other indices that you have to use to test fitting model, right? So this fitting model will help you to confirm your model is fitted based on your data, not in general, your data, because maybe fitting model in Indonesia data is confirmed, but in Malaysia data, no, it's not confirmed, right? So even you prepare a research framework, you have to do the fitting, maybe fitting this model that you prepared or framework that you prepared in one population accepted, the other population is not accepted. And based on you're a statistician, mathematician, you know that if the model is not fitted, it means there is some problem in your data analysis, some problem you collect in your data, even some problem for matching, the variable inside the framework. So you have to think about it, how to redesign your model, right? This is the long story. I don't want to go for it. I just want to give you some roughly information about the structure equation model, almost an application of structure equation modeling in research. Okay, now we move on. This is the basic feature of the Amos, right? As you can see here, there are some bottom in the left side, and you can design your framework in the right side. Normally, I never put, the name of the bottom in my mind. I'll just follow, the picture or the feature of the bottom or the symbol, here. But if you want to know the name of the bottom one by one, I put it this slide here. Maybe this webinar is recording, and after that you can refer and then go back to look at the definition of the bottom here, right? So if I'm talking so fast, I'm so sorry, because I would like to transfer so many information roughly about the structure equation model in 1 hour and 45 minutes, right? So as you can see here, the main part is a manifest variable or measurement variable, well, as we talking about before, as a representative of OL, and then here we use it a lot for the adding indicator. This is, about that. This is, it's so clear. If you want to move your object, you have to use this kind of truck. It's so funny truck. So if you want to copy your objective or data, it's like that. You can use this one. If you want to reshape, you have to use this kind of symbol, right? Sorry, Dita, can I ask you what time I should finish my slides?
Okay, Dr. Hashem, you have 90 minutes and will end at 1 hours more.
Oh, so I have 1 hour, right?
Yeah.
Oh, good. Thank you.
Okay,
thank you, Dita. I'm so sorry to bother you, because time management is very important for presentation.
Okay, thank you.
I appreciate that. Okay, so I have 1 hour. Hopefully,
Yes.
I can finish it during the 1 hour, right? So, and then there are so many icons, and then you can learn by yourself, and then because not is the right time, I teach you one by one, right? So for the Amos, I put this as 3 or 4 slides later for the beginner, and then you can learn about the Amos step by step, how to specify conceptual model. On Amos, first, we should open the data set, and then draw and run your model, and then evaluate your model. That's all. 3 steps. Open the data set. Sometimes you put your data in Excel, SPSS, or text. And I would suggest you always save your data in Excel file. Don't save your data in SPSS, because based on my experience for many years, SPSS software is very sensitive. And sometimes your SPSS open with this computer, with this version of the SPSS, but cannot open the other version of the SPSS. So this is the main issue for the SPSS: saving data, not data analysis. I'm talking about the saving data, right? So it's better you save your data in Excel file, right? And then, so when you open your, and then draw and run your model, and then evaluate your model. That's all, right? This is the bottom that I mentioned here. You can see is
kita nge-scan barcode-nya punya kita apa punya cabang?
You can see the bottom of here that for the setting up the data, select the data, and then file name, and that's all. Okay. And then for designing the models, for example, we have 2 type of the variable here. One here XPM, and then true 2, for example. And then you have to design based on this option. And then when you want to set your data here, this is the option. You have to use that, right? When you use this option, this window is come up, right? I will teach you later, but this is for your reference if you want to go back and then open and then watch this video again, right? So you go for the model specification, you design the model here, and then here you will learn about it, and then give them the name. Even here, if this is the dependent variable, you have to use for this one for the error of the dependent variable. And then still model specification, we need this kind of bottom 1, 3, 4, and then this bottom 2, when you click for this one, this is appear, right? And this window is very helpful for you, right? You can see that for the direct and indirect effect, you need this window, and then factor score weight, beta eyes, right? Covariance estimation, and then test for normality. Wow, you need all this kind of stuff for just from this one. So after that, you run your data based on here, right? So when you run your data based on this bottom, you can see there are 2 bottom here. It's very important. So when you click on it and it becomes like this one, you can see the output is appear here, right? Coefficient, variance, or something like that, right? Unstandardized coefficient and standardized coefficient. We talk about it later. Just I put this some slides, especially for the beginner who wants to use Amos software from the beginning, right? So now move on the application of the Amos. So consider I have this framework, right? And this framework is borrowed from the education area, social science. And here I have dependent variable, it's called academic performance. And I have one independent variable, parental socioeconomic, and 2 mediator, health and quality of life. So I have dependent variable, independent variable, independent, and mediator 1 and mediator 2, right? So this is design, of course, is very simple one. I would like just teach you how we do the data analysis with the Amos, right? So, okay, I put this framework in Excel file, as I told you before, and this is the framework. Normally, I also put the framework in the Excel, and then very simple copy and paste based on choosing like this one, very fast. Very fast. I'm really one of the fan of the Excel, right? So I just copied this one to Word file and then I my paper. No need you do, you see, very fast. You can just go this one and then that's all, right? You don't need to design your framework inside the Word. I saw some of my students, they do the design, the research framework inside the Word. For every space or tab, all of them, they're moving around. So I advise you, as I said, do it in Excel file, right? So as we can see here, we have 4 latent variable. So the next step, we should show the measurement of the variable, right? So have parental socioeconomic, quality of life, health, and academic performance. For the parental socioeconomic, we have 1, 2, 3, 4, right? It's like I just give you this, variable, sorry, for the 1, 2, 3, 4, 5. Father age, mother education, father education, family income. Normally, in my papers, you can see for the parental socioeconomic or household environment or household socioeconomic, I use these 4 or 5, sometimes 6 measurement variable, right? So parental socioeconomic, how many measurement do we have? We have 5, right? So father age, all of you guys you know about because you are a statistician. Luckily, I don't need to explain more. So you are coding father age, you are coding education, and you are coding family income, right? So let's move on to the quality of life. For the quality of life, I found some literature about the quality of life is around 15 or 16 indicator, but I extract 9 of them because it's suitable for my area. Sometimes you found some papers or some theories that they put 6 or 7. You have to justify why you use that 6 or 10 or 9 indicators in your latent variable. So as I said here, quality of life, here I put 9 indicator, which is actually selected from 15, if I'm not mistaken, between 15 to 17 indicators, right? So this is, okay. Oh, there's a question. Oh, it's not mine. Okay. Okay, maybe I can answer this one later. Yeah, slide presentation will be shared. Sure. Yeah. Okay. So quality of life, normally all of us, we know that we go like a scale, right? But my advice based on the statistician and experience about these years, I would like to suggest my student and my collaborator, we go for 9 like a scale. Why? Right? First of all, I put a line between, right? Between, as you can see, I put a line here as a moderator because I want to know there is a board between, for example, left side and right side. What's that, the left side and the right side? Sometimes you use, okay, satisfaction, agree or disagree, but you have to make sure there is a line between the satisfaction or dissatisfaction or agree or disagree. This one thing. The more important thing, as I said here, I have 1, 2 until 9. Why? Because one part of the structure equation model or Amos software or structure equation model process is normality test. If you have less variation, for example, 1 to 4, the probability of your data become non-normal is high. But if you make it more, a variety from the nothing to full, right? I mean, for example, not satisfied to very satisfied, totally disagree, totally agree. If you put more number between them, the probability of your data become normal will be high. So that's why I put this one. Of course, if your data is not normal, you can go Bayesian structure equation modeling. But uh, from the beginner and from the normal researcher, it's better you have some normal data, right? So let's go back. So quality of life, 9 variable, health, 5 variable, physical health, mental health, and behavioral health, and academic performance, 3, and also these are data, right? So I come up here like showing, yeah, normally from the beginning, you have to do the measurement variable. Measurement model, sorry, I'm so sorry. Measurement model. For the measurement model, you have to go for the factor loading. Of course, you have to go for the reliability, validity. There are a lot of process, but I teach you the main one because as I said from the beginning, just for the Amos software, I need around 3 days to teaching you from the introduction to advanced, right? So first of all, you have to come up with this kind of designing for every latent variable that you have here, right? So you come up with this one, for example, as I said, for the parental socioeconomy, right? We have 1, 2, 3, 4, 5 measurements. So I designed parental socioeconomic like this one based on the father age, mother age until the end. Like this one for the selecting data. And then, as I said, for analyst properties, which is very important, especially this part, output, right? And to come up some information about the analysis of, right, structure equation modeling. So from the beginning, you have to come up with a measurement model. So for every latent variable, you find factor loading. What's the factor loading? So as I said in our slide here, when we do the analysis of data and then run the data and then we click here, you can see there is some numbers here. It's called it factor loading, or sometimes call it coefficient impact of the parental socioeconomic over the measurement variable, right? So there are two types, unstandardized estimate and standardized estimate. And I would suggest you use the standardized estimate because you're a statistician. I don't need to explain what's the meaning of standardized estimate. So as we can see that the factor loading of these 5 variable, all of them can see that, for example, father age 0.94, mother age 0.52, mother education 0.32, and then father education 0.26, and family income 0.71. So there is a rule, of course, you will read later, for the factor loading. Sometimes you have to consider you eliminate for every latent variable, eliminate every measurement measure variable if their factor load is 0.7. Some people, they said no, the criteria is 0.5, right? It's up to you and it's up to your supervisor if you want have more accuracy in your data analysis, so you go for 0.7. But I also saw some of the paper, they do accept the 0.5. The main reason they put the 0.5 because they want to lose less variable. because every variable give information to the model, but every variable eliminate from the model, even is not, what does it call, is not very high significant, but still can affect inside the model. So that's why some people put 0.5. So from the beginning, you go for this one, and I save it, for example, socioeconomic initial, because I mean, put all of them. So as I said here, you can see factor loading of the, for example, mother education and father education is less than 0.5. So I eliminate these two measurement variable from the latent variable. So I come up with the socioeconomic final here. So I save it as a different, right? So when I do the data analysis or run the data, right, you can see that these factor loading are higher than the 0.5. So you can see that. So even for the analyzing factor loading, almost software is a graphic design, right? You can design very simple. You can design, you can simple, and then you can add the variable, and then you can, give them the name or something like that. It's very easy, right? So so that's some people see I can move it for here, you see, until here, very easy. So some people advise for go for the graphic, especially for me as an applied statistician. I'm not most of my research is applied statistics. I don't go for the formula. So for the applied statistics, and I advise to the student, is better they go for the graphic model first. And then when they understand the structure of the graphic, and then they can, imagine what's the correlation between the dependent variable, independent variable, mediator, moderator, right? And then if you like, you can go for the coding. For the coding, R is one of the main famous, and some people, they go for M+, even some people for Python, right? So I suggest you, if you want to start for the structure equation modeling, start with the Amos. If you want, you can go for the R also, but Amos will give you to understand, to imagine the research framework in your mind. So for everything that I, for example, here, I do the framework, by the end, I can imagine in my mind, right? So that's why Amos is so good for the beginner. So that's why we put the Amos, as a part of like this international webinar, right? Let's go back to our topic. So as I said, we have 4 latent variables we have done for the parental socioeconomic, and also I did here, like for example, quality of life initial, and then here you see I put 9 of the indicator, and then on run the data, and then I saw here you can see that, right, the factor loading of every measurement variable with latent variable. So I eliminate this one, and they go for the final, quality of life, right? So this is the first part you have to do for the every latent variable. So also for the health, you can see the output here, and after that, I eliminate, for example, emotional health from the rest of the data analysis. So this is the main criteria. So, and after that, for us, you can see all of them maybe they are higher than 0.5. So we keep them all, right? So this is the first part for the factor loading analysis or measurement. And the second one, which is go for the measurement model. Measurement model, as I said here, right? As I said here, you can see just latent variable with measurement. So as you can see here, just measurement model, correlation variable from the model. So I put this one as a measurement variable, right? Sorry, measurement model. So when we do the analyze, they give this kind of information, the correlation among latent variable without considering, their situation inside the research framework, right? So one more thing, you have to see that is the correlation. For example, the highest correlation you can see between socioeconomic and academic performance. It's so logic, right? So is 0.8 socioeconomic health, 0.6 socioeconomic 0.67, quality of life 0.56, health, blah, blah, until the end. The one test you have to have the measurement model, and the correlation between the latent variables shouldn't be that high, right? Some theories, even some of my paper, I mentioned 0.85. If the correlation between every two latent variables is less than 0.85, we accept there is no multicollinearity among the latent variables. As you can see here, right, the highest one is health, and the academic performance 0.84, which is less than 0.85, right? So multicollinearity is not happen the measurement model, right? So we finalize, everything's fine. Now we go for the last part, which is called structural model. Do you remember we're talking about the structural model and path analysis, which is added some other variable, right? Which is maybe dependent variable, mediator, or something like that, right? So what we can do here, we design, let me, I move this window over. We design a structure model like this one, right? So I designed this structural model. As you can see, so clear. You can see socioeconomy is the independent, academic performance is this independent, academic performance dependent, and to mediate the quality of life and health. So when we run the data, and then you can see that here, right? So this is the last part. Of course, before that, there are some fitting model, normality test, or I haven't done it because it's, as I said, it takes so much time. Just here is the introduction of the Amos, right? So, okay, as you can see here, one of the, we're talking about this one run the data, and we talk about these two bottom. Of course, we had some simple information about this one. Now we should view the text. When you click on the view text, it's showing that moreover, you can see the correlation or coefficient of the socioeconomic over the quality of a 0.44, right? And the highest one is belongs to socioeconomic over the health, right? So as you can see here, this 0.94 is R square. The R square is quite high. You know that what does it mean, the R square? For example, here is 0.94. What does it mean? It means 94% of the variation of academic performance is depend on health, quality of life, and socioeconomy. The rest is 6%. There are some variable we don't know, right? So this is the R square. You can see the R square is quite high. So let's go back to have some information about, like, you can see there are some information here. You can go for estimation. The estimation showing you based on the critical ratio, p-value, which one is, has the effect, significant effect or non-significant effect, right? So moreover, also we have model fit here. Do you remember for the fitting the model? You can see CFI 0.92, TLI 0.89, and then IFI 0.913, and then RFI, and then so you can see that normally your model should be fitted. So if your data, your model is not fitted, you have to go for modification indices. right? So this is the thing that you can, you know, you can see if the model is not fitted, you go for modification indices. This is another story. You can learn how to analyze the modification indices and then, you know, come up with the final model. So consider I already done the modification indices, and then you can learn by yourself later. And then you come up with the final structural model. You see, we realize that based on the modification indices, there should be correlation between the father age and family income, and also between the quality of life and school attendance, right? So this is the final model based on the model fitting. As when you run the data, this is the thing that you have to put in your thesis as a final. Of course, the file indirect content syntax error, okay? So almost indirect simply test, okay. Why it's not working? Okay, do not estimate, okay. How about now? Right, okay. So now you can see that this is final model, and then this is red value is call it, for example, R square. R square of the impact of the socioeconomic over the quality of life 0.34. Socioeconomic over the health 0.52, and then 3 of them over the academic performance 0.49. Even you can see the correlation between already mentioned here, right? So so this is the final model. So this is the thing that you should come up with your you know, with your data analysis with the Amos for the final part of Amos. The most important thing of the Amos is like how you interpret. That I suggest my student, especially a PhD student, I suggest them, moreover, you learn about the Amos. Amos is one part, it's 5%. Even you know the Amos, you know the research framework, you know everything. If you do the Amos, it's 5%. 95% how you interpret your model, how you interpret your data, how you interpret your output, how you interpret your output with the descriptive statistics coming some idea, which is contribution of your study, right? So moreover, you have to learn Amos, you have to improve your knowledge how to interpret your model, right? This is the good job of a statistician. Statistician is not just coming, oh, the correlation is 0.56. Okay, well, what's the point of 0.56? What's your suggestion? What's your solution? The good statistician, based on the data analysis, come up with the new idea for the business strategy. Before that, I was, before I came here, I was a lecturer in Iran, and also I was working for the airline industry. My job was the business strategy expert. I prepared 6 pages, but this value, how to improve the profit of the company based on the data analysis, right? Because you have to prove that how you come up this idea based on the data analysis. So the most important thing, how you interpret your data, how you interpret your output. So I think this is enough for the talking about the Amos. Dita, can I have, how much do I have? Half an hour or less?
30 minutes more, Dr. Hashem.
Okay, 30 minutes. Thank you. Right. So this is the thing I would like to start as an introduction of. So how we use this structure equation modeling in your thesis. This is another story. I would like to share my knowledge with you, how you know, we write your master thesis or PhD thesis based on the structure equation modeling. So since the structure equation modeling came to the data analysis, the structure of the thesis also is changed. So here I would like to, you know, give you 10-step for preparing research thesis based on the structure equation modeling. Right, this is my experience for many years. Even I've done my PhD with the structure equation model in 2013, if I'm not mistaken, right, with the airline industry, and then bring performance modeling for the airline industry for my PhD thesis. So this is my experience, 10 steps for preparing research thesis based on the SEM. This is the thesis structure. Every of us, we know, we have 5 chapter: introduction, literature review, research methodology, data analysis, discussion, and conclusion, right? So when I talk with my student, for the first thing, I ask them, what is the statement of the problem, right? I don't, oh, you read this one, you read this one. No, read something related to your topic. For example, what is your statement of the problem? If the education, what's the statement of the problem, right? It's a part of the introduction. You can see that. So a statement of the problem is the main key, right? So if my student wants to do structure equation model, I say, find statement of the problem first. Second, I would like they know about the theoretical and conceptual framework. I mean, research framework, right? After statement of the problem, I ask my student, find theoretical and conceptual framework. You know that the differences between conceptual framework and theoretical framework. Theoretical framework, it means the models, those models have done before, somebody have done before, they prepared before. Conceptual model, you combine together, and then you add or delete something based on your area, based on population, based on the situation, call it conceptual framework. Conceptual framework is your model, right? Is your research model, is your contribution, right? But theoretical model is like previous study related to your topic. So first, I ask the student, find the statement of the problem. Second, very fast, I would like to see your research framework. Because if you have your research framework, you have everything. You have a statement of the problem, you have contribution of the study, you have objective of the study, you have the research question, you have research hypothesis, you have, even you can predict your discussion. You can predict your contribution, can predict your novelty of your study. So the second part, research framework. So first of all, which area you want to work? You want to work obesity, you want to work leadership, supply chain, student attitude, or job satisfaction. So problem statement, you have to read the previous study. House, for example, if I want to go for the academic performance, I give you an example here. Academic performance, there's thousands of variety of the studies about the household environment can affect the academic performance, school environment, and peer influence of the academic. But currently, based on the, for example, pandemic situation, we will have online class like now, right? Live. You are in Malaysia, some of the Iran, some of the Bangladesh, some of the China, some of the Korea. Now I have a class in Korea, right? Because of the pandemic, right? So one part is good. We can communicate and you learn. We can, based on the live, we can still transfer our knowledge, but I still have some problem, right? So COVID-19 will teach us how to force us to adapt us to do the online, right? Like we are doing right now. Maybe every hour sitting in your house, and then I'm also sitting in my house Saturday. Yeah, even even you have online class, there is no weekend, right? You are just sitting here from 9 based on your time, 8 based on your time. It's a Saturday. You have to enjoy your life in the weekend, but no, online teaching force you to join your class, right? This one another issue. What should we do? It can affect your academic performance somehow, yes, somehow no, and then how? Interpret, right? So this is the current study, COVID-19 and online classes, right? So I found previous study and current study, right? So for example, now as a hot topic, COVID-19, how can affect to the online classes and academic performance? This is step one. I found a issue, right? Since step two, determine main objective of the study, right? So maybe could be evaluate online classes during COVID-19, student satisfaction level on online classes, and evaluate student academic performance and introducing a process or package on online classes, something like that. The main objective, you have to find out. The second one, my best friend, Google Scholar. I love it. Since 2013, I become this friend. Before, yeah, I go to this website, go that website, but since 2000, I think, if I'm not mistaken, not 2013, 2009 or 8, I start to make a friend with this kind of database. It's awesome. I don't teach. Yeah, you have to go for the, other website. Even I forgot their name, like Elsevier but the best friend is Google Scholar. I teach my student how they find a topic based on the Google Scholar, right? So, okay, find, read based on a theoretical framework based on Google Scholar. For example, you can put this one. You go for the in the left side here is like advanced research, and then for example, you write online class COVID-19, the main keyword, and then you put the title here as a title, right? Just these two. And then I found step 3, 4 papers totally related to this topic. For example, paper 1, paper 2, paper 3, and paper 4. Impact of environment. So this is my theoretical framework. Sorry, there are some variables and modeling inside these 4 papers related to online class and also pandemic and academic performance, right? So I this one, put all the framework together. You see, paper 1 have this kind of framework on the left side: academic performance, lighting, noise, temperature. And then paper 2, also parental support, teacher support, and stress academic, right? And something like that. And then paper 3, there's a correlation between the stress, fear COVID-19, and well-being. And also in paper 4, for the dependent variable, I use this kind of, you see? So structure equation modeling is just a process. You should follow based on the process. Don't panic. So just, oh, structure equation model problem is so big. No. But if you know the way, if you know the path, one by one, you go for it. So after my student know about which area they want to go, I asked them, find 4, 5 paper related to your topic. So they give me this kind of, maybe sometimes they give me 10, and I choose around 4 of them among them, and we combine with them, I come up with a new framework, right? So a statistician can do that because you understand very well more than the normal people, right? So this is my framework. Even I'm working for this project, and hopefully it's going to publish very fast. So like this one, combination of the framework together, right? And then come up with this idea. And then this one, like there is a path here, moderator here. And then also, sorry, is control variable. Right? So this is the framework. If I have this one, I can come up with everything. Statement of the problem, research question, research objective, hypothesis. Even I can get some discussion, right? So with having a conceptual framework, you can objective and research question, prepare research hypothesis, prepare some part of significance of the study, and prepare some part of contribution of the study. As I said, sorry, before. Now we go step 4. Step 4, how to measure the variable, right? If you go for the obesity, we know that obesity is formula. Sorry. Education, we go this one, number of 8 or something like that. Next one, prepare your questionnaire. So you design environment, everything, and then you prepare your questionnaire. And in step 6, revise research question, right? You come up, normally I ask this, my student come up with 3 research question in a structure equation modeling. And after that, we go for Cronbach alpha and reliability and validity. After you find the Cronbach alpha, and then you revise the questions, pilot study, right? For the pilot study, you should come up here. You go for the reliability and validity. Also, the main one is Cronbach alpha, and after that, revise your questionnaire. Rewrite some question, add some question, or eliminate some question. If you see some theory, it doesn't mean you have to put all of them. You can choose some question based on your area. I'll give you example. For example, Malaysia is a Muslim country, right? Indonesia is a Muslim country. So drinking alcohol is not part of the study. So we don't use it, right? This one in our variable, right? So it is the step 7. And then sampling process, it's up to you. Go for online and then how, and then collect data. And then after that, you start writing chapter 4. After data analysis, you go for starting chapter 4. It's so common, right? So the thing that for this, another thing that I suggest my student to do this one. And here, for the structure, I advise them chapter 4, the structure based on this one. First, descriptive statistic. Second, data analysis for the first question. Third, data analysis based on the second question. Fourth, based on question 3. Why? Because normally for the Viva, especially for PhD student, they said, oh, which part of your analysis is related to question 1? Which part of your analysis is related to your objective 2? How relationship between your objective 2 with research question? So this is the main questions come up for the external and internal examiner in during your Viva. So if you well prepare, so what I'm saying that well prepare your output, very classified. This is descriptive statistics. I have to put that, and this is data analysis based on question 1. Question 1 is objective 1 and objective 2. Question 2, objective 1 and objective 3, and then question 3, objective 3. You see, if we are well prepared, this question is not coming to the external examiner because they can see, you know, the flow of your output. Even the slide, I suggest my student to put their slide based on the output of the analysis based on the question 1, output analysis based on the question 2 and 3, right? So after data analysis, I suggest my student go for literature review now, because you know how to do it, you know the output, and you have to learn about prepare your literature review. 10 to 12 paper related to your topic, you know about that. That's one. This is the background of the study. So literature review is more extensive knowledge, right? That give it to you. So now step 10, I go for the chapter 2, right? So now you have chapter 2 and chapter 1, and then chapter 5, discussion, and then conclusion. So this is the process. Sorry, I go very fast because I would like to finish my syllabus today. So this is the process. I always chapter 4, 2, and 5, and then chapter 3, and then chapter 1. Because chapter 1 always change. Research objective is changed. Research question is changed. Always change, and even significant of the study, because after you do data analysis and interpret your data, you found something new. So you have to also revise your chapter 1, right? So this is the thing that I would like to suggest you 10 steps how to write your thesis, prepare your thesis based on your based on the Amos, based on the path analysis with the structure equation modeling. Now the last part, I would like to give you some information how to prepare your paper, especially for the high-rank journal, and based on the SEM analysis, right? So, okay. So the first paper, like I published in healthcare, which is Q2 is maybe is around 2 point something impact factor. And this is the current one. You see, the statistician keyword is there, adolescence obesity modeling, right? Because we introduce a framework. So you can use that adolescence obesity modeling, a framework of socioeconomic analysis on public health. This is my paper, that the current paper 2021, which is, collaborate with my colleague, right? And then as you can see here, we come up this framework, right? So normally I advise my student to have moderator, to have mediator. You can see it here. One of the contribution of this paper, I put that there is a correlation between BMI and body fat, right? Sorry. And the journal is approved, right? So framework, my main contribution is framework. And after that, you see that the process of the writing paper for the sampling, you see descriptive statistic, right? And then when descriptive and the factor loading, reliability and validity, you can read this paper. It's like a basic thing. And then, as I said, one thing I would like to suggest, but not from the beginning, you do comparison analysis among 3 estimators. Estimator, because we have a structure equation, one maximum likelihood estimator, partial estimator, or Bayesian estimator. But it's quite advanced. I don't suggest you from the beginning right now. Even after 2 years, maybe experience about the structure equation model, you can go for the Bayesian, because Bayesian need more knowledge about the structure equation modeling. So this is the, very basic thing based on the Bayesian structure equation modeling. And then this is the final model, right? Adolescence, girl, and then boy also here. And then we're talking about the moderation analysis. You see, even sometimes you have to give this kind of diagram for this one. And then by the end, yeah, you see, look at how the discussion. So you have a statistician, you have to have very good discussion. The second paper I would like to share with you. This one for one of my PhD students is about the postpartum depression symptom in survey based on a structure equation model. Also, a BMC Public Health. I think you're aware of that, and I'm here as a corresponding author here. And this one also, we design a framework, right? You can see most of my paper, I design a new framework. Depression, BMI, lifestyle, healthy food, and unhealthy food intake, right? So, as I said, descriptive statistic from the beginning, and after that factual loading, and then the structural model, and then this is the relationship with the significancy. But also sometimes you put some, for example, longitudinal with the modeling, so time 1, time 2, and time 3 as a future study. It's called a dynamic SEM framework, right? So I suggest here. And then this one also, right? You can see that this paper is published in International Journal of Environmental Research and Public Health, is also S.Si. And also I have done it with my student and my colleague. I'm supervisor and co-supervisor of the student. And then body mass index and demography, lifestyle, mental health, and postpartum woman. Also a structure equation, modern approach. You can see all the same. Design a new framework, how to deal with the research variable, and then that's all. This is the way. Please look at this paper. You can give you how sample size based on structure equation modeling, right? So by the end, you see all kind of the CFI, RFI, fitting model is a part of it. And then by the end, we come up descriptive statistics, reliability, validity, normality. This is the, you see Cronbach alpha and then factor loading between the rural and urban people. And then this is the normality test based on the Shapiro-Wilks and Anderson Darling test. And then see fitting model, right? NFI, CFI, TLR, do you remember? Talking about this one. And also modification indices for the final model. And this is the another way. So come up with this one, rural and urban. But the last two papers, as a statistician, you can come up with better idea with combination of a structure equation modeling with other simple methodology, right? I give you example. If you look at this paper, also published International Journal of the Environment, Research and Public Health. So I'm also here as a corresponding author, and you can see that analysis of obesity among Malaysian university students. The best part is here. You're a statistician. We like when we see this kind of type of the topic. A combination study with application of Bayesian structure equation model and Pearson correlation. Very interesting, right? After we did analysis with SEM, we come up with some idea, some information based on the Pearson correlation. Not from the beginning. After that, after you finalize your model, you see that this is the model, this is the framework we designed, right? After we designed, we did all the team Bayesian structure equation modeling, right? You see, this is the Bayesian structure equation model with bachelor and the master and PhD. And then this is the thing that always I teach you today. So I put in my paper. Sorry. So you can see until the end, yeah. Correlation analysis after structure equation. It's very interesting, right? It's because there's an idea behind it. Why I did that? It's very interesting. I would like to read this paper. And then you can see that this correlation, we didn't consider it because it's eliminated from the previous part of data analysis. It's interesting. So you can see that even a structure equation model, and then the last one is the best one that I said. I published this paper in 2018, right? Effect of the social media on childhood obesity. The interesting part, application of structure equation modeling with Taguchi method. Maybe you haven't heard about it. Maybe Prof. Eridani is a mathematician, knows about the Taguchi method, especially engineering statistics. And then, so after I come up with the model, I come up with the pattern. So pattern is a Taguchi method from the engineering. So this is the, can say this is the first part. I put the Taguchi method in public health. Actually, it's from the engineering, it's experimental design, right? So you can see that after I'm talking about this, the process of the Taguchi method, after our analyzing the structure equation modeling, and then this is the framework. After that, we come up with this output, which is like this one is multicollinearity also I did here, and then decoding based on the Taguchi method here, and then this is the output of the Taguchi method diagram. I don't want to go into it, but Taguchi method give you pattern. Structure equation model give you a model, but pattern is different than the model. Maybe if you like, we can read about this paper. Especially Taguchi method is very helpful. So even you, by the end, this is my summarized word. After you learn, you have to know how to interpret. After you know how to interpret, now you can combine different methodology because you extract some information from the first part and use it, that data for your next analysis, right? I think this is the, I finished my presentation for today. Dita, did I finish in the right time or no? We still have time.
You still have only
Okay.
5 minutes.
Okay. Good. It's still good. Yeah. So this is my presentation today, and I'm so happy to present you this international webinar structure equation modeling. And if any question, I would love to hear, and then if my knowledge is enough, I can answer it, or maybe I can help you for your data analysis, or you're preparing your research. Okay, I'm ready for that. Thank you. So Dita, the screen is yours.
Okay, thank you. Wow, what's amazing topic. Very, very clear explanation. And we know Amos is very good for beginner. Yeah, with Amos we can imagine the research in our mind, and we get the tips from you how to build our topic research and to prepare paper for high rank journal. Thank you so much, Dr. Hashem.
Yeah, thank you, Dita. I can see some question here, and then of course one of them definitely I will share here. So Dita, I should give it to you, or I can share inside the participant. What should I do? I don't mind if I.
Okay. Okay. Yeah. Now we will start the question answer session. Okay, Dr. Hasim,
Yeah.
for 15 minutes. There are a question in chat room from Mr. Sudiono. I will read.
Yeah, sure. Yeah.
Okay, the question from Mr. Sudiono is, from your presentation, it was said that the SEM model is a combination of path analysis, regression based on research. The model is said to be good if the prediction result of the data from the model would have relatively small errors. How to predict data using SEM?
Okay. Predicting of the data with the SEM is totally like how should I say, like regression. After you you write the model, you have to know how to write the model. I think it's one of my paper here already put the type of writing, if I'm not mistaken. Yeah, here, definitely here. You can see that for equation 1, 2, and 3, you can predict, right? You know how to predict. You put some variable for the x1, x2, and x3. You can find the BMI level for the different level. So the prediction, you should write like regression. It's like here, you can see that, right? So next one, next question.
Okay, if it's clear, Mr. Sudiono, or to confirmation?
Okay.
Okay, please,
Enough,
Mr. Sudiono. Oh, enough.
Your answer,
okay.
Yeah, enough. Okay.
Okay, thank you, Mr. Sudiono. It's enough. And then we go to the next question from Ms. Rianti Setiadi. How to use categorical data?
Categorical data, actually SEM more focused on the continuous variable. So that's why for categorical data, which kind of categorical data? If, for example, gender and like male and female, is better you use for them as a moderator. It's not just a part of the, how should I say that? Not part of the independent or dependent variable. We should be careful for the categorical data. If categorical, there is an order among them, you can use them in dependent variable, independent, and mediator. But the categorical is based on the, for example, gender, and based on the, for example, geographic situation among two countries or two cities. You cannot put inside as the main variable, for example, dependent, independent. I saw some people, they put gender as an independent variable in structure equation model and is published in high-rank journal. It's not correct. So they can use it as a moderator, right? So this is my answer. It depends on which kind of categorical data you have. Right? Who is to ask this question? Right?
Okay. Thank you, Dr. Hasim. I will ask Ms. Rianti Setiadi.
Yeah.
Any confirmation more from you, Ms. Rianti?
Thank you very much, sir.
Okay.
You're welcome. You're welcome, Ms. Rianti. Right?
Okay. We go to the next question in the chat room. From Mr. Ardi Kurniawan, is there journal of Q1 or Q2 that discussing about result in special apply of SEM?
Yeah, there's a journal, it's called it structure equation modeling. Even the top journal is about the structure equation modeling. And if I'm not mistaken, they have, and especially it's better you go for journal with psychology and human behavior. They are more towards, they use applied statistics. So if you want, you can email me. You have my email, and then I give you some, because it's not in my mind right now, but I can find some of them. Total is about the structure equation modeling, but generally it's better you go human behavior or psychology. They are so good for a structure equation modeling. Yeah, that's
okay,
all
thank
from
you.
me. Yeah.
Okay, thank you, Dr. Hasim. In psychology and human behavior.
Yeah.
Okay, we will send your email to Mr. Adi.
Yeah.
Okay, Mr. Adi, this is enough or any confirmation?
Miss Dita, yeah, thank you, Miss Hasim.
Okay, thank you, Mr. Adi. Yeah, we have next question from the chat room. From Mr. Adi Wijaya, in SEM, we have two common approach, covariant based and variance based. According your experience and research, which one do you prefer?
Actually, I don't prefer any of them. I do based on the data analysis, right? Which one is suitable? Which one give us, fitting model, and then that indices that I teach you has the lowest one, and then give us the high R square, right? And for example, and this paper, let me. You see, normally, sorry. Not this paper, just hold on, please. Sometimes I refer to these indices. See, sometimes I go for the R square and Ramsey, right? And then based on the output of this one, I decide which one is better, right? It depends on you, but normally I try to, analyze first which fitting model is suitable for my data. Yeah, this is my answer for this question.
Okay, Dr. Hasim, analyze first with fit data. Okay, Mr. Adi Wijaya, any confirmation? Okay, no. Thank you, Mr. Adi. We have 7 minutes left from the question and answer session. Please, if you have a question, you can chat in our chat room, or you can use a raise hand icon to ask Dr. Hasim directly. Okay. Any other question from your participant? Yeah,
There is
one
no
more
question.
question. Okay, next question, Dr. Hasim from the chat room.
Yeah.
One month,
Mhm.
the number from Miss Dian Handayani.
Mhm.
1 month, the number of respondent is 250 based on the sample size. Is it okay if I will conduct test hypothesis? For example, I will test the significance about direct, oh sorry. Okay. Is okay if I will conduct test hypothesis. For example, I will test the significance about direct effect or indirect effect. I collect sample data via online survey because of the time limitation. I just collect the data only for 1 month. Okay, add
Yeah.
to question. Yeah, collect sample data via online survey, only 1 month. The number of respondent is 250 based on the sample size. If it's okay, I will conduct test hypothesis. For example, I will test the significance about direct effect or indirect effect with the sample
Very
size.
good. Yeah, correct. Thank you. Data, actually, both of them are two good questions. The first one for the Rosa Aziza, I would like to suggest you, and I put normally for my paper, mostly I put for the structure equation model is better talk with the, some evidence rather than I say there is a table or something like that. I want to, because some of them I write inside the text, but I found this one. Oh, yeah. I share screen with you again. All right. Can you see that?
Okay.
Yeah. See, you see, this is the table. I always use this one based on the Herb Black in 2000, I think 10 or 14. Is the based on the sample size, based on the number of the latent variable. It's not, we can say 250 is good or 300 is good. No, it's based on this one. I always use this theory. So to calculate my, sample size or number of the participant. You see, if you have 100 participant, research model contain 5 or less latent variable, and each latent variable cover at least 3 indicators. Even, for example, 500 should have more than 7 latent variable, and some of the latent variable cover less than 3 indicators. So, for example, if I have more than 7 latent variable, definitely I should go for 500 because of this theory. And then if you go for a moderation analysis, you have to gender, boy and girl, you have to go for the 1000 at least, right? This is my perception, and always use this theory for how because this is a critical question, and the always reviewer ask you, right? The reviewer ask you, so based on the which theory you go for this one. So for the Rosa, I think this is for you, but for Dian, normally for PhD student, we ask more accuracy in their data analysis. But for master students, especially master by course and research, we are a little lenient. So we don't very follow this strict rule. But for the PhD, yeah, really we go to, and then we cannot say honestly 1 month is enough or no, it's not enough. This is not limitation. You have to spend more, right? So this is my perception, and also this the answer of the external examiner. They said you have to spend more. You are a PhD student, right? So normally I use this one, and also I suggest my student to use this table to confirm that they are following scientific way for collecting data. So this is the answer from me. So, but I would like to also hear about your opinion.
Okay, thank you, Dr. Hashem. The question from Miss Dian and Miss Rosa Aziza. Any other confirmation from Miss Dian and Miss Rosa? Okay, maybe it's enough.
No.
Okay, thank you so much. Yeah, this is the end our question and answer session, 15 minutes, and I would like to say thank you so much to Dr. Hashem. What amazing presentation. We know about implementation, the SEM with Amos, and then we know about the measurement model and structural model. And yeah, as you say, 95% is how to interpret.
Yeah.
So we have to improve our interpretation, what is conclusion and what is the suggestion. And as a statistician, we know more than the normal people.
Yeah, yeah.
Okay.
Correct. So
Thank you so much.
You're welcome. I just share my slides,
Okay.
data for the student, if they can. And then,
Okay.
I already sent. If the student wants my slide, I love to share this one with my, friend and then student. Yeah, that's all.
Okay.
Thank you, Dita.
Thank you so much, Dr. Hashem. I hope we can meet
You're welcome.
another time in another discussion. Stay healthy.
Sure. Yeah. Thank you so much. Thank you so much.
Thank you.
Yeah. Thank you,
Prof.
Thank you. Yeah. Thank you so much.
See you again, Dr.
Sure, Prof. Yeah, it's my pleasure. Yeah. Just this collaboration started. Prof.
Okay.
We wait the collaboration.
Yeah. We have done before.
Okay.
Dr. Fariz know me from before.
Okay.
Here the keynote, and then also keynote speaker. Lom. Okay. To see you. You all.
Yeah.
Thank you.
Okay, yeah.
Okay, thank you so much. It's the end of our first session. Now we have a short time to break, and I leave it back to MC. Thank you.
Okay, thank you very much to our moderator, Ms. Dita, and our keynote speaker, Dr. Hashem. Before we start our second session, we will take a break for about 10 minutes. To the committee in charge, please. The time is yours.
Assalamualaikum warahmatullahi wabarakatuh.
Thank you. Special music from Dita.
Okay. Thank you for the opportunity. Peace be upon you. First of all, I would like to introduce myself and my partner. My name is Dita Santi and my partner is Antonio. For a while, we will guide the session to have a break time and to have a nice breaking. Our session aims us to have fun for a while by playing games. So before we proceed to the game session, I would like to explain the rule of the games anyways. So the game is about guessing the draw. Basically, both of us, me, my partner and I will draw the clue of the word. The participant must and the participant must guess the word by seeing the draw that we have drawn. So for any further ado, let's start the game. Okay. So I will present the whiteboard. Yes. So the first one who will draw is my partner. So for Mr. Anton, you may draw the clue. And participant, you may answer or guess the word, but into the microphone, okay, not into the chat box. Okay. Okay, so anyone know what this? Okay, so you may answer into the microphone, you know how to guess the word. Okay. Anyone? Okay, or I would like
Is it
to.
thunder?
Okay, it's thunder. So with talking, we're going to the next clue. I will draw the clue. Okay, wait for a while. So anyone know what is it? It is rain. Okay. So whom I'm talking? I'm sorry. Okay. Thank you. Well, the next, Mr. Antonio, you may draw.
Antonio.
Well, anyone know this? What is it?
Cherry, maybe?
Apple. It's not cherry. Apple. True, it's apple. Okay. Yeah, it's apple. Okay, we'll go into the next one. It's getting interesting because everyone participate actively. Well, wait for a moment. I hope you can guess this. Okay, Mr. Sudiono, you guess all the words. Okay. Okay, anyone know what is it? Okay, wait for a moment. Yes. Back. True, it's back. Okay. You may draw. He used to cook. So anyone know what this? It is used to cook. Yes, it is pan. Yes, with who I'm talking?
Apaan?
Okay, thank you, Miss. We're going to the next. Okay. It's quite complicated to draw, but I think it's easy to guess. Wait for a moment. I would like to answer it.
The map.
Indonesia.
Yes, it's map. Yes.
Good.
It's map. Okay. Well, we're going to the next one.
For the camping.
No, it's for camping, but the word is not camping.
Tent.
And yes, it's
Tent.
tent. Okay. Well, going to the next one. It's quite easy. Okay, wait for a moment. I would like to draw this as clear as I can. Okay. I think anyone will know it. Anyone knows what it? We directly put this. Yes, it's lamb. Yes, exactly. Well, we're going to the next one. Mr. Anton, you may draw.
The picture no good.
Okay. Okay. Yes. So it's the part of our body. Okay. It's the part of our body.
Hand.
Oh.
No, it's not the head.
Hand.
Yes, it's the whole body.
Arm.
Yes,
Arm,
it's an
yeah.
arm. Yes,
Exactly.
exactly. It's an arm. Okay. But it's also very easy. So I would like to draw as clear as I can. M.Si. Okay. So basically, we use to as a student, I often use it.
And pencil.
Yes, it's a
Pencil.
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 Okay.
Clear pencil, clear.
Yes, it's a pencil. Okay. Well, we're going to the next one. Okay. If Mr. Random may draw. We when bath anyway. So we take a bath. So basically, this game is depend on how we are in drawing.
Sure.
Okay.
But,
It's water.
water.
Towel. Towel.
Yes, it's
Towel.
towel. Yes, exactly. It's towel. Okay. Well, this one, it's also quite easy. Wait. Okay. Okay. Yeah, we use it on our head. So we use it. Okay, on our head. I will put the title. Okay, anyone knows?
It's on our head.
It's yes, it's hat. Exactly. Well, next one. This one.
Wah. Rain. Rain.
No, it's not rain.
Winter.
Oh, snow.
No.
No.
Yes, it's snow. Okay. It's snow. The next one. It's quite easy. I think all of you have this in. Yeah. Well,
Table.
Very
Yes.
easy.
So easy, right? Okay, the next one. Yeah, sometimes you may draw the clue. Okay. Use it every day. When we have yes,
Laptop.
it's a laptop.
Laptop. Clear laptop.
Okay, it's clear laptop. Okay. Well, the next one. Wait, sorry. Aduh. Wait for a moment. Okay, is it?
Left.
Yeah,
Yeah, nah.
my okay. Cuman Mr. Anton, you may draw. Okay, so easy. Yeah, this is for. Okay, well, this is next one.
Bottle.
Yes, it's bottle.
Bottle.
Exactly. The last one, so we have arrived to the last one will be drawn by Mr. Anton. You may draw.
Suitcase.
Okay. Yes, it is book. Okay. Well, this is the last of this. That's the end of this. This also the end of this breaking time. Thank you so much for participating in the session actively. That's all from us. We give back to the MC. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you very much for the committee.
Dita.
It's really a fun game. Now, after the break, we will begin our second session. Our keynote speaker for the second session is Mr. Fariz Fadillah Mardianto from Universitas Airlangga with the topic of Introduction to Structural Equation Modeling and its implementation with R. The session will also be moderated by Ms. Dita. To Ms. Dita, the time is yours.
Okay, thank you, Miss Rani. Thank you for the fun ice breaking, improve our imagination. Still with me, Dita, your moderator today. Okay, we're ready to continue our discussion with another great speaker. Please welcome Mr. Fariz Fadillah Mardianto. Sorry.
Okay,
Hello, Mr.
no problem.
Fariz.
Hello, Miss Dita.
Okay, how are you?
Fine. And you? Fine?
I'm fine, thank you.
Okay, thank you.
Okay, our second speaker is Mr. Fariz Fadillah Mardianto, lecturer of Statistics Study Program, as a coordinator statistical for Economic and Social Science Research Group, Faculty of Science and Technology, Universitas Airlangga. In this session, the speaker will present the topic for 60 minutes, and then will be followed by a question-answer session for 15 minutes. To participants who will ask question can write in chat room on Zoom or YouTube, or you can use raise hand icon after the speaker present his presentation. Mr. Fariz will present about introduction to structural equation modeling and its implementation with R. To Mr. Fariz, time is yours.
Thank you, Miss Dita. Okay, the nice method of ceremony, moderator. Okay, okay. I will share our screen. Okay. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
This is okay. Thank you for your attention. This is the last session 2, from webinar about structural equation modeling, and I would say thank you to all of participants, especially outside Indonesia, who can attend this event. Okay. In this session, we will discuss about structural equation modeling and its implementation with R, and we have some real example based on real data. And I will introduce myself. My name is Fariz Fadillah Mardianto. I'm a lecturer in Statistics Studi Program Universitas Airlangga. And this is our research team for data preparation. My students, they are Christopher Andreas. Christopher Andreas will help me to share or to demonstrate our example in R. And then Mr. And then Antonio Nicolas, and then Haidar Arsif Firdaus, and Hieroglyph Fahri. Okay, my name is Fariz, Fadillah Mardianto. My email for correspondent, you can contact this email, and then this is my WhatsApp, and my education background. I bachelor in mathematics, ITS Surabaya, and then master in statistics ITS Surabaya, and doctor in mathematics, Universitas Gadjah Mada. And my research interest about statistical data analysis, especially about structural equation modeling, and then regression analysis, and etc. I have been become a data analysis instructor in national and international level events that were conducted both by offline and online, because pandemic, the offline agenda is limited. Okay. Okay. When doctor in this
Sorry,
previous.
Mr. Faris, can you share your full share screen or
okay,
your PowerPoint?
Okay. Thank you. Pardon. Okay, wait for. Okay. Clear, Miss Dita?
Wait, still
Loading.
Clear.
Okay. I will continue, Miss Dita. Okay. Hello, Miss Dita. Okay. And in the previous section, Dr. Hashem has already shared about his publication, and in this session, I also share about my publication or our publication with a team. In this case, the first publication is about comparative analysis of the competitiveness between Indonesian movies against international movies as a reference in developing Indonesia's cinema and curriculum about cinematography. And this publication, we use SAM, structural equation modeling, and I say SAM when Dr. Hasim say SEM. Okay, no, it doesn't matter. And then the second one, my publication is about prediction the number of students in Indonesia who study in tutoring agency and their motivation. I combine between regression modeling and structural equation modeling. This is one of part my dissertation. And then the third is about analysis of factor affecting competition. Again, about competition in battle drinking water cells in Madura. And then the fourth, analysis of factor affecting youth motivation in Madura to improve education with the structural equation modeling. And the last one, the publication in 2021 about July. The title is Influence Factor about the Compliance of Madura's Community related to COVID-19 Health Protocol based on structural equation modeling partially squared. And then I still have some publication in national level about SEM or structural equation modeling. Nah, in this part, I just make addition or make a completion with Dr. Hashem slide because some of part has already discussed by Dr. Hashem in previous session. No, as you know, that motivation of that include many variables, and then to model specification, model modification, and model comparison, and then visualize research model in a graphical form, analyze variables that can be measured directly on, or in this case, I say unobserved variable, and then test model which have 2 or more sample, in this case, multi-group analysis conduct. Okay, in the question and answer in the chat room. Maybe Mr. Adi said that SEM there are two types. Okay, that's right. In the structural equation modeling there are two types. The type is covariant based SEM and then variant based SEM. Variant based SEM is famous called by PLS SEM, and then covariant based SEM has already discussed by Dr. Hashem. As you know that Herr et al. Recommend that if the goal is predicting K target, construct or identifying K, refer construct select PLS SEM. And if the goal is theory testing, theory confirmation or comparison of alternative theory, you can select the goal for the respondent or the sample size. The determination of the minimum sample size for SEM is 10 times number of indicator. I prefer or I sit ahead at all 2011. But don't worry, the minimum requirement
Recording in
this case
progress.
is about open source R, and open source software R can be used for both of them, covariant based SEM and variant based SEM. Okay, this is covariant based SEM. I will skip it because I think Dr. Hashem has discussed and my PowerPoint or my presentation. This is partially square. Okay, partially square. PLS is a powerful analysis method and often referred as soft modeling because this method excludes assumption that exist in ordinary least square, and like residual doesn't have to be that normal distribution. So when you use a covariant based structural equation modeling that already discussed by Dr. Hashem, the data is not normally distribution, so partially square approach can become an alternative. PLS doesn't require the use of large sample size. Moreover, various level of measurement such as categoric and then interval and ordinal could be included in the sum model. This is model specification. There are inner model and then outer model and weight relation. You can see the meaning of inner model, outer model, and weight relation in this slide. Okay. Okay, and then in PLS or partially square, sometimes we need bootstrapping process. Bootstrapping is one of resampling method or procedure is to create pseudo data using information from the original set of data by paying attention to the original data set so that the pseudo data could have characteristics that are similar to the original set of data. And in this case, bootstrap process can be used to resampling the sample size in the PLSM when you use smart PLS software. But in the structural modeling, developing a structural model based on theory equation, and then input matrix selection and model estimation, and then you can evaluation of the problem identity, evaluation criteria or for goodness of it. Dr. has discussed their normality and then multivariate outlier, and etc. Multicollinearity and similarity. You can learn in from this slide. And then this multivariate normality test as a general description. Okay, the goodness of it is T squared, RMSE, etc. And the goodness of it test have a cutoff value. This is the cutoff value. Okay, the model is good or satisfied goodness of it condition when 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 it you can or the criteria of level that related level of reliability. This is very high, moderate, low, and very low. Okay, validity of a contract can be observed from factor loading or standardized parameter estimate. And before declaring that the relationship between construct with their corresponding indicator are valid, we have to make sure that the factor loading are already significant. Based on convergent validity, the level of validity is accepted when the value of factor loading is greater 0.7 and greater than 0.5 based on Ghazali's book in 2017. So we have two choice. You can consider 0.7 or you can consider 0.5. Okay, in this case, we use open source software R. Why we use open source software R? Because the strength or the benefit is no license, minimum counter vetting, like to use comprehensive feature and complete. With open source software R, you can make analysis about structural equation modeling, path analysis, confirmatory factor analysis, and structural equation modeling based on variant or SEMDLS. But the weakness, I think, based on the researcher, yeah, because the weakness is programming skill. Nah, programming skill are needed. Users are required to install packages less user friendly. Okay. R is when when we become a beginner programming. I mean, R is difficult. Amos is very easy than R, but when we focus on we want to study or learn about programming, I think structural equation modeling with R it doesn't matter. Okay. Okay, this is sign meaning for structural modeling in R. This is some symbol. Okay, in this case, sorry. Yeah, okay. This is X is correlated to Y. X is independent variable. Y is a dependent variable in this case. X can be mentioned as exogenous and Y is endogenous variable. And then this symbol means that Y is replaced by X. And this the third one, latent variable X consists of indicator Y and Z or reflective latent. And the last is factor X is formed by indicator Y and Z or formative latent. It should be familiar when you use structural equation modeling with open source software R. Okay, this is the session 2 about confirmatory factor analysis. I have one case study and I will simulate with R. Okay, the example is according to the Ministry of Health in Indonesia, a person is said to have COVID-19 when that person has symptoms of fever, cough, runny nose, fatigue, diarrhea, rash, and a PET diagram or framework. Okay, this is the framework or PET diagram. Okay, so positive COVID-19 can be affect. We will investigate whether positive COVID-19 can be affect based on fever, cough, runny nose, fatigue, diarrhea, rash, and etc. And then we make a symbol C1 until C7 for the latent variable. Okay, this is maybe in this case, Mr. Christopher, my student can demonstrate our script in R. Okay, Mr. Christopher, the time is yours.
Okay, thank you, Mr. Fariz.
Okay.
Okay, my name is Christopher, a student of Statistics Study Program in Universitas Airlangga. On this occasion, I will show you a tutorial on solving a case study with structural equation modeling in R. And for the first one, this is about confirmatory factor analysis. As we know that in R, we need packages. For confirmatory factor analysis, we need 3 packages. There is Lavaan, SemPlot, and SemTools. Okay, now I will run this script. Okay, now we can see this is the results. Okay, for in R console, we can see this is the summary of the results. And for standardized solution, for mid measures, and also for reliability.
Okay, I will explain
Okay,
the result. Thank you, Mr. Christopher. Okay, for multivariate normality test, you can see the output about p-value in this case. In this case, p-value is 0.746. It means the condition is greater than alpha when you use alpha 0.05. It means that accept null hypothesis and the conclusion data are multivariate normal distributed. So it can be continued with confirmatory factor analysis. Okay. And then this is the goodness of it. You can make a table to make your justification become easier. But in this case, okay, all of goodness of it, most of goodness of it index will satisfy the cutoff value. For example, for t square, cutoff value to 3.68479, but the result is 10.213. Is it less than cutoff value? And then the significant probability greater than cutoff value, and then the RMSEA less than cutoff value, and GFE greater than cutoff value. GFE is good also, and AGFI okay. This is AGFI, and then is not greater, it's not greater than 0.9, but don't worry, model is acceptable. But don't worry, we will investigate about reliability, significance, and validity related to result. Okay, this is the goodness of it criterion. Okay, this is the indicator significant test with the null hypothesis. The indicator doesn't contribute in the construction of latent variable, and the opposite is the indicator contributes significantly in the construction of latent variable. We reject null hypothesis when p-value less than alpha. In this case, that p-value all of p-value is less than alpha. Yeah, in this case. Okay, so we reject null hypothesis. It means that the indicator contributes significantly in the construction of latent variable, and this is the R-square value. Okay, this is the result that related indicator significant test. This is the validity and reliability test based on R output. Based on the result, the level of validity is acceptable because the factor loading are greater than 0.5. Sorry. Okay, this is all of factor loading greater than 0.5 for its latent variable relationship with their corresponding indicator. The ideal validity is aimed by the relationship between positive with a C4 equal by C4, and the level of reliability is also acceptable because the alpha or omega is greater 0.7. This is the result for reliability test. Okay, so it means validity is in good condition and reliability is in good condition, and the goodness of it for previous slide is mostly satisfied the cutoff value. Okay, and then you can investigate using variant extract and construct reliability test. This is you can determine the AVE and CR value, and then this is the interpretation. Based on the interpretation, we can see that all of indicators significantly track the latent variable, which is COVID-19 symptoms. Indicator C4 or fatigue give the biggest contribute to the latent variable. Why? Because the R-square or determination coefficient is the biggest one when we compare to all of indicator. Therefore, it can be confirmed that fever, cough, and then runny nose, fatigue, diarrhea, rash, and loss of taste or smell are factors that describe COVID-19 symptom or the person that infect COVID-19. Okay, this is the the example, the first example. Okay, and then the next session we go to about PET analysis. Okay, PET analysis procedure. This is the step to perform PET analysis. The first is develop a research model based on concept and theories, and then make model assumption test, interval or ratio scale of the variable. The second linearity and observed variable is measured without error or measurement instrument should be valid and reliable. And the last, the relationship way in a system. Okay. PET coefficient analysis, you can determine PET coefficient analysis and you make check model validity, and the last is interpretation. Okay, this is the second case study that related financial case. Okay, the case is Financial Service Authority in Indonesia called OJK assume that some economic indicators such as interest rate, return of asset or ROA, return of equity ROE, and non-performing loan NPL percentage can affect bank growth. Therefore, OJK wants to test how those variables are related to each other by using PET analysis. As many as 50 conventional banks in Indonesia that are observed, the data obtained are ratio scale data in percentage of bank growth, ROA, ROE, banks. The first process. Okay, this is the normality. And again, Christopher, Recording in progress. The name is part1.txt. The data can be made as txt file, or maybe you can combine with Excel file and etc. And you must be careful to make the pattern using the syntax. Okay, this is the pattern or the syntax for make the pattern that suitable or on your path diagram. Okay, and then this is make a fit model, and then activate fit result and make summary. And this is in special for path analysis we have correlation, so we perform GG core to make output equation modeling and structural equation modeling partially squared. In the next example, you can without write syntax but GG core, and this explanation about the syntax in there are some participants who asking me to share about how the syntax. Okay, thank you, Mr. Christopher. Okay, I will continue to the next discussion. Okay, this is a multivariate value. In this case, the value is now 0. Then 0.05. So data is multivariate normal distribution. And then this is the goodness of fit test. Okay, to make easy, you can make table in according to the table. Most of goodness of fit index, the result that related goodness of fit index has satisfied a cutoff value. For example, significant probability greater than 0.05, and then GFE greater than 0.9, and etc. So you can make conclusion that in general the model is acceptable. Okay. The next one is about validity test. Validity test can be conducted by using F-squared, which indicates that percentage of the variance in the dependent variable that the independent variables explain collective or simultaneous. In our software, the F-squared for each variable are obtained as follows. Okay, this is based on the R result, and based on the test result of rate from bank growth by 5 point. Okay, and then about return of asset, 32.9 about E, 57.9 about non-performing loan. Okay, you can calculate make calculation about validity test using the formula, and you can calculate with do some syntax in R, or you can do it with Excel. In this case, we use Excel to determine R squared M. Based on the result, the combination total percentage for the path diagram is 89.58%, which means that the percentage of variance that can be explained by the path diagram is 89.58%. In other words, there are 89.58% information that can be explained by the path diagram. The information can be explained respond the question.
Recording in
learning
progress.
education and lecture recognition. Okay, this is the PET diagram. Okay, this is the normality test. Okay, there a question. There is a question in the chat room from Miss Rianti Setiadi. What method do you use to check multivariate multivariate normal test? We can do automatically with art syntax modeling. Okay, this is the R output. Nah, the R output in this case is the result of this is automatically appear in your output, but you can investigate that the result is same with the multivariate normality test as general as you use based on multivariate literature or multivariate reference. For example, using Johnson and Wichen and Clencher about multivariate normality and etc. Okay, okay. Maybe for the third example, Mr. Christopher can demonstrate.
Okay, Mr. Fariz. Okay, now is for the third example. This is about structural equation modeling. And of course, the script, this is especially in here, it depends of your model. So you can read, okay, now this is, I will run the script.
Recording in progress.
So, similar with previous example, in this case, we have p-value 0.087. It means that p-value condition is greater than 5%. So, the data are multivariate normally distribution. And then this is the goodness of it test, and it can be easier when you make a table as follows. Okay, in this case, in general, the model is acceptable because mostly the result is have fulfilled or satisfied with cutoff value. For example, about significance probability, and then RMSEA, GFI, and etc. This is the hypothesis test that related significant test for its indicator. Okay, we can see the R output. In this case, p-value from all of indicators are already in the interval less than 5%. Okay, you can see that. So the conclusion, all of indicators contribute significantly in their corresponding latent variable construction, which are lectures, credibility, quality of learning method, attitude towards student, and lecture recognition. And this is the regression parameter significant test. It means that we reject null hypothesis because p-value less than alpha or 5%. This is the hypothesis for its parameter. And then the next one is interpretation based on regression parameter significant test. Okay, the interpretation X has a statistically significant effect on response variable Z1. Okay, because the p-value less than 5%, and then X has statistically significant effect on response variable Z2. Okay, and then the last Z1 and Z2 have a statistically significant effect on response variable Y. So the conclusion, all of parameters have a statistically significant effect on the response variable. In other words, lecture's credibility has a significant effect on quality of learning method and lecture attitude towards students. As an addition, the quality of learning method and lecture attitude towards students have a significant effect on lectures recognition. Okay, this is the conclusion, and this is the validity and reliability test. All of a loading factor is greater than 0.5. Based on the result, we can conclude that all of indicators are already valid. And this is the S-squared. So the variance of data that can be explained by the research model based on the result in R, the average of R squared or determination coefficient is 0.422 or 40%, about 40%. Therefore, the model can explain the variance of data by 40% or 40.2%. Okay. Okay, and then the level of reliability for of latent variable. The level of reliability could be assessed if the convergence alpha, omega, or average variance value is greater than 0.7. Based on the test result, the data are already reliable because the convergence alpha and omega are already higher than 0.7. Okay, the last is final formation of the path diagram with the result in R. But I think the path diagram in R, if we compare with Amos, is great. The visualization is greater Amos than R. But when you make your skill about computation, maybe you can combine the path diagram. So in R software, the visualization of path diagram will become better. Okay, and then the last is about SAM-PLS. This is the last method. Okay, we use structural equation modeling partial square or SEM based variant. This is the analysis procedure. The step 1, develop a theory-based model and then create a path diagram. And the step 2, parameter estimation and then model evaluation. The step 3, model interpretation and make conclusion. If the result from model evaluation show that the model is not valid or reliable, then we can consider 2. The first, exclude indicators that aren't valid or reliable. So you throw the indicator that not make your model doesn't valid or doesn't reliable, and then you can make a model or the estimation process. And then the last is modify the model or the construct, but you must be careful because the model must be suitable with the literature, because this is confirmatory factor analysis, confirm the literature or confirm the reference. Okay. And then model evaluation in SEM-PLS and reliability and validity, we use loading factor. This value has to be higher than 0.7, same with previous method. And then otherwise, loading factor that range from 0.6 until 0.7 are still acceptable in explanatory research. And or you can use average variance stack up, or AVE. AVE has to be bigger than 0.5. And then you can use reliability measure. There are two choices. You can use composite reliability or converged alpha. Composite reliability, this value has to be bigger than 0.7, but the level of reliability can still be accepted if the composite reliability values are bigger than 0.6, or you use converged alpha. This value has to be bigger than 0.7 in confirmatory research, otherwise lagging factor higher than 0.6 are still acceptable in explanatory research. And then the evaluation of the structural model for inner model, you can use determination coefficient or R-square. The criteria of R-square are classified in three categories, which are R-square of 0.67, and then 0.33 and 0.19 as substantial, moderate, and weak respectively. Okay, 0.67 substantial, 0.33 moderate, and 0.19 weak. And the second, you use significant level. You just compare p-value and alpha. Statistically significant if p-value less than alpha, or alpha greater than p-value. Okay, the last, you can use goodness of fit different with SEM. In SEM PLS, the goodness of fit just one formula. You use JOF. Okay, there are three criteria or three categories to interpret goodness of fit index. Okay, JOF small when less than 0.1, and then KOF medium when the value between 0.25 and 0.36, and the last KOF large when the value is greater than 0.36. Okay, you can explore in the related reference. Okay, this is based on Chin in 1998. This is the categories of R-square or determination coefficient, and this is when we refer to high at all. Okay, which one that you choose? I mean, you must make you must see, or you must make you must be careful that this is can be accommodated or can be used according to your data, to your research, according to your purpose of your research. I mean that. Okay, this is the last example about structural equation modeling partially squared. Okay, the Ministry of Manpower in Indonesia will evaluate the pre-employment training course which is affiliated to the ministry. Okay, about labor area, yeah, the last example. Hopefully, the performance of the course can be maximized. Therefore, the Ministry of Manpower hires a statistician to analyze the quality of the affiliate pre-employment training based on the related variable as follows. They are based on tutoring, advising, value, and satisfaction. Data in this research were obtained from survey that input 180 course attempts as respondent in Indonesia. Okay. This is the case work about latent variable and indicator. The first one is you should draw the path diagram as your framework, and this is the latent variable and then indicator. Okay, this is the difference between inner model and outer model. The left is inner model and the outer model is exogen or endogen variable with the manifest. The manifest. Okay, or the indicator. Okay, this is the difference between inner model and outer model. Okay, before I explain about model evaluation, maybe for the last example, Christopher, my student, can demonstrate in R. Okay, Christopher, time is yours.
Okay, Mr. Fariz. Okay, now for the last example, this is about structural equation modeling partially square. To run this script, we need one additional package. There is SAM in R for additional package. And this is the script. Okay, now I will run this script.
Okay.
Okay, and in the script, in R, we can also do bootstrapping.
Yeah.
But we must wait some process in here.
Okay, this is the difference between the previous example. We have bootstrapping process. Yeah.
Okay, there is SAM in R successfully bootstrap. Now we can see the result of bootstrapping. This is the result of bootstrapping.
Okay.
And last, we can see the plot of the model. Okay, maybe I will share again. Okay.
Okay.
There is the plot.
Okay.
This is for SAM-PLS model, and the last we can see the plot of bootstrap model.
Yeah.
Yes, there is the bootstrap model.
Okay.
Okay, thank you.
Maybe you can perform the syntax. What package that different with previous package? Okay, for SAM-PLS, you need package SAM in R, and I mean just SAM in R. Okay, maybe you can scroll down, Mr. Christopher. Okay, yeah, just SAM in R. Okay, thank you, Mr. Christopher, for your time. Okay.
Okay, thank you, Mr. Fariz.
So in this case, we interpret the result. The last example, the first one is model evaluation. Based on the result in R, okay, in outer model, its indicator can be declared valid if its outer logic greater 0.7. Okay. And then all indicators used in this case are valid. This is the can be summary in this table. Okay. And then for validity, we use AVE, average variance extraction. When average variance extraction greater than 0.5, then the variable has fulfilled the convergent validity criteria. If converge alpha greater 0.7, then the variable has fulfilled the reliability criteria. There are two condition or two requirement. You use both of them, but when you use one of them, it doesn't matter. Okay. In this case, all variables used in this case are already valid and variable. Okay, this is the average value are convert alpha in this case greater than 0.7. Okay. And then the next method evaluation about determination coefficient or R square. The criteria of R square are classified in three categories, which are 0.67, 0.33, and 0.19. And in this case, the determination coefficient value is 0.412 or 41.2%. It can be categorized as moderate. And then for variable satisfaction, the R value or determination coefficient value is 0.72. It means that the R square is in substantial condition, 72%. Okay. And the next one is about goodness of fit index. Okay. The GOF is 0.633254. The condition is large because greater than 0.36. The model has a large goodness of fit, and then this is the average variance extraction greater than 0.5, and this is the R square that we discussed in previous slide. And about bootstrapping result, let's look at this bootstrapping result. When T statistic greater than T in table, we can conclude that the parameter has a statistically significant effect on the endogen variable. Okay, on endogen variable, it means a dependent variable. According to Trujillo 2009, the table 1.96 is often used at level of significant 5%. Okay. Okay, we can use T-stat. Okay, T-stat. Okay. Okay. This is less than 1.6, 1.96. Sorry, 1.96. So it can be concluded that tutoring has a statistically significant effect on value, and then tutoring doesn't have a significant effect on satisfaction. Advising has a statistically significant effect on value and satisfaction. And the last, value has a statistically significant effect on satisfaction. Okay. The suggestion to make better improvement, you can eliminate or you can delete satisfaction, and then you make re-estimation without value, and then advising and tutoring. Okay, it's similar with linear regression as usual. Okay, this is the final form of SEMPLS model, and then this is the bootstrap model. Okay, the development of SEM can be used for moderation and mediation effect, Bayesian and non-parametric approach. In SEM, Bayesian approach has been discussed by Dr. Hashem in his paper, and the implementation of SEM using other statistical software, Amos, has been discussed by Dr. Hashem, and then Smart PLS, Listel, Giska, and etc. Okay, I mean this is the our presentation or our explanation. Thank you. Hopefully today's topic can be implemented in the other case studies. If your experiment is statistic, you will get a better experiment based on Ernest to support as a scientist. Okay, time enough. Uh, I will go to the moderator, Miss Dita, to question and answer session. Thank you
very much for your presentation, and thank you so much to Mr. Christopher for demonstrate to us why R, because R no license legal to use, have comprehensive feature, but the issues is programming skill. It fits you.
On presentation have been said, but unfortunately for syntax R, the data so other source. Okay, I'm so sorry.
Okay, thank you, Mr. Fariz. Okay, go through the next question from Mr. Adi Wijaya. In your presentation, it was said that PLS SEM does not require data distribution assumption, but in the third case study, there is an examination of the multivariate normality assumption. Why is this assumption still being made?
Okay, thank you for Mr. Adi Wijaya. Okay, based on the literature or based on reference, PLSM, that's true. It doesn't require data distribution assumption, but we just perform that the data when the distribution is normal multivariate is also good condition when we model PLS SEM. Okay.
Okay, thank you, Mr. Fariz. Any other confirmation from Mr. Adi Wijaya?
Enough.
Okay, thank you, Mr. Adi Wijaya.
Okay, thank you, Mr. Adi Wijaya. Go through the next question. Okay, Miss Rosa Aziza. In model evaluation in SAMPLS, if we make for one-tail significance level.
Okay. Okay, in this case, we use when we use one tail significant level. I mean, I'm not sure, but I mean, you can make membuat kepastian itu apa, Bu Dita? Make information or make supporting
Miss Rosa Aziza, any confirmation?
Okay, Miss Rosa, maybe you can discuss in the outside the webinar.
Okay. Okay, thank you. We go through the Miss Kismiantini.
Okay.
The output in the model test user model do not test the multivariate normal distribution. Instead, the chi-square test p-value here determine whether or not the model fits to the data.
Okay.
Statement.
Yeah.
Any response, Mr. Fariz?
Okay. For this statement, the output in the model test result do not test the multivariate normal distribution. Instead, the chi-square test determine apakah whether or not the model fits. Yeah. My response is very short. When we use factor analysis, path analysis, and then structural equation modeling based on covariance. So we need normal distribution assumption. So we need to test or to investigate whether the data normal distribution or not. But when you use structural equation modeling based on variance or SEMPLS, you just you will when you use a normal multivariate test is okay, but if you pass the step or without using multivariate normal distribution test is not problem. It doesn't matter because SEM-PLS, SEM-PLS is a structural equation modeling doesn't assumption.
Okay, thank you, Mr. Fariz. And next to the next question from Mr. Sediono. How to solution by using SEM method to especially multi-effect COVID-19 to respect education in Indonesia?
Okay, thank you. The solution using SEM method to multi-effect. Okay. In this case, this is an interesting problem, yeah. To develop
hot topic today.
Yeah, hot topic and develop our first example. First example related COVID-19. Maybe in this case you can you need or we need more exploration or more analysis to get the related or the specific data. Maybe. Yeah, because I never get a research that related to multi-effect COVID-19.
Okay, thanks.
Maybe
thank you.
visit with Dr. Hashem.
It's enough, Mr. Sediono.
Enough.
Okay, thank you. And then go to the next question from Mr. Adi Wijaya is needed to determine the magnitude of each latent variable to the final endogenous variable. But in your presentation, I have not seen it. In this is
Okay. Maybe Mr. Adi Wijaya can ask to me. Can using your microphone?
Okay. Mr.
I need
Adi.
confirmation. Yeah. Okay.
Yeah.
Yes. It's clear, Mr. Adi.
Clear ya.
Okay, clear.
Clear ya, but not present danger ya.
Yeah. Okay.
Okay, glad to discuss with Mr. Fariz ya. Nice to meet you, Mr. Fariz.
Okay, nice to meet you.
I also study about especially in PLS sense, so it is nice for me to enhance my knowledge from your.
Okay, hello.
However, based on this, they said that we need to report the exercise. Yeah, there are two of exercise, F square exercise. However, in your presentation, I can see
Recording in progress.
Some literature magnitude quantity. Okay, yeah. Okay, magnitude quantity. Okay. Maybe you can share what literature that refer about magnitude quantity and maybe in outside the forum I can share the literature that in SEM-PLS is not only it doesn't properly it doesn't must it must not using magnitude quantity. Okay.
yeah. Thank you, Mr. Fariz.
Okay.
Thank you, Mr. Adi. It's enough.
Okay. For all participants for discussion, you can contact my email and my WhatsApp number. Okay. My email and my WhatsApp number is in the slide, the beginner of slide. Okay, maybe for to make clearer, you can speak with me in Indonesia or English and etc. Okay.
Thank you.
Yeah,
I have done your presentation.
Okay. Thank you.
Okay, thank you so much. It's the end of 15 minutes for question and answer session. It's an amazing topic from the two speaker. And Dr. Hashem also stay with us from beginning. Thank you so much, Dr.
Thank you, Dr. Hashem.
You're welcome. You're welcome.
Okay.
Yeah. I'm also
Thank you so much
learning
to-
something. Yeah, sure. It's a sharing knowledge here.
Yeah.
Yeah.
Okay, thank you so much for our great speaker today and our great participant too. It's very amazing discussion. Hope you can enjoy the discussion and improve knowledge about structural equation modeling. As a moderator, I apologize if in the discussion make some mistake. Thank you so much. Stay healthy, everyone, and I look back to.
Traveling places I have seen you in ages, but I hope you come back to me. My mind's running wild with you far away. I still think of you 100 times a day.
I still think of you too. If only you knew. When I'm feeling up at town, I don't wanna pull through. I look out for your photograph and I think how much I miss you. I miss you.
I wish you knew where I was, 'cause I don't have a clue. I just need to work out some way getting me to you, 'cause I will never find love like ours so true. Million years, million years.
My location I know, try to find a way back home to you again. I gotta get back to you, gotta get back to you. My location I know, try to find a way back home to you again. I gotta get back to you, gotta do.
I just need to know that you're safe, even that I'm out away. On your first flight back to your side, I don't care how long it takes, I know you'll be worth the wait. On the first flight back to your side.
I don't wanna be wasting time without you. Don't wanna throw. I need you. Something tell me we'll be alright. Yeah. Something tell me we'll be alright.
I don't want to be wasting time without you. Don't want to join. I need you. Something tells me we'll be alright.
My location unknown, trying to find a way back home to you again. Gotta get back to you, gotta get back to you.
My location I know. Try to find a way back home to you again. Gotta get back to you. Gotta get back to you.
I just need to know that you're safe, given that I'm also away.
Care how long it takes. I don't know. We work for it on the first flight back to your side.